Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at coding style and how to make your code more maintainable. When it comes to coding styles and techniques, I am not seeking to impose a particular style on you. I tend to take the Bruce Lee method in this one. If there's a style or technique that works for you, then use it. If there's a style that does not work for you, then discard it. The users of your software generally don't care what you've programmed the application in. They don't care whether it's PowerBasic or .NET. What they mostly care about is the functionality of the application. If you're working for an organization with a large number of programmers, you may find they will impose a coding style upon you. The reasons for this are quite straightforward, as the code you write may well be maintained by other programmers. It has to be readable and understandable easily. Even within PowerBasic, it's quite easy to write code that will be difficult to maintain and manage. For example, if we're going to write some code here, we can quite easily at the beginning of our program create a constant. Now, there's nothing syntactically wrong with this. We're creating a constant called a, and we're assigning the value 7 to it. Now, I've put no comment in here to say what the constant's actually for, and the name of the constant isn't terribly helpful. But syntactically, there's nothing wrong with that. We can also go ahead and do some dimensioning and creation of local variables. Here we've created an array. This array is called a, and it has a dimension of 7, set by the constant we've used. Now, it's mildly confusing the fact we're using two a's in here, but it can get considerably worse. We've now created a local variable called a as a long. Now, if we attempted to compile this program, it would compile quite cleanly, because PowerBasic quite happily can differentiate between a as an array and a as a long. It treats them as entirely separate variables. However, it's going to start getting a little bit confusing as we go further on in the code. If we create a for next loop, we can take it from a equals 1 to the upper bounding of a. That's a as in the array a, not a as in the long. And it gets worse. We're now assigning a value to the element of the array, which is called a, and the element we're referencing is also called a. And again, this would compile. And if we send that out to our log, and we run our program, it will run quite happily, differentiating between the a as a long and the a as an array. Now, of course, looking at this program, it may make sense to us because we've just created the program. But if you have to come back and look at this program 6 months from now, a year from now, 5 years or longer, would you still remember what the logic behind the creation is? Although we can see what the program's actually doing, it's quite obvious. It's a for next loop. What we're not sure about is what's the purpose of this array. What's it for? There are no comments in the code. The name of the array isn't terribly helpful. While this is a very short function, and all the dimensions and variable declarations are on the same page as the variables we're using, so it's quite easy to see that we have both an array and a local long named a. If this function was 200 lines long or longer, then the setting up of the variables would not be visible on the same page, and it could become extremely hard to follow the code. It would also be remarkably easy to pick the wrong a and use the long variable rather than the array, and then wonder why your code's doing something really strange. So naming of your variables is very sensible and makes the code much more maintainable. If we do a bit of renaming, things will become clear. Now, by simple renaming of our variables, it becomes more obvious what we're actually doing. We're keeping track in an array, which is the number of visitors per day. There are 7 days, and we're stepping through the days from 1 to the upper bounding of the array. So if we try running that now, we'll find it gives us exactly the same output, but the code is much easier to follow. So naming your variables in a sensible way makes it easier for you as the programmer to follow the code, and also for anyone else coming along in a few weeks, months or years later and actually picking up and amending your code. The style I tend to use when I'm setting up variables is to prefix each variable name with a short mnemonic. As in my variable here, which is day, I prefix with LNG for long. So anytime in the code when I come across that variable, I will know that that is a long variable. My arrays I always prefix with an A underline and then followed by the type of the array, str for string, LNG for long, dbl for double. Now traditionally, when variables were set up, you could actually declare your variables like so, specifying a suffix at the end of your variable to define that as a long. Now, while that will still work perfectly well within PowerBasic, you may well come across code that other people have created where they're using the suffix approach. There's nothing wrong with that, as long as you know that this particular symbol means long. But personally, I prefer the long-handed way of doing it. To me, it's more obvious. So now that we've named all our variables sensibly, what else can we do to help make our code more maintainable? Now, as you'll have seen at the top, we have included 2 include files at the beginning of our program. The first one is the one that ships with PowerBasic, which is the Windows 32 API library. In addition, I've created a number of libraries in the Libraries folder to do common functions. The advantage in having common libraries is much to do with how many programs you're going to be writing. If you're only ever going to write 1 or 2 programs, then common libraries don't really come into their own. If you're writing dozens or hundreds of programs, then they very much do. There will always be a certain number of functions that you won't call in your program all the time. Functions to see if your application is already running, functions to load data from files, and functions to call many other things. Putting this code in a library means that you can easily scan all your source files to see if the library you have just changed means that some other application needs to be recompiled to pick up that library. We did a video a while back on continuous integration. That's a good approach to take if you're doing a lot of development, so that every time you change a common library, you basically recompile all your applications to see that if the change you've made to the common library is going to functionally break something in one of your other applications. That way you won't be surprised when you're pushed for time to change that other application at some point in the future. But this has just been a short introduction to code maintainability. That's it for today. Thank you for watching.